Welcome guys, welcome to our channel EduWorld. So in this video we are going to talk about motion in a straight line, and if you like our videos, then obviously in our videos, share our videos, comment in our videos and subscribe to our channel. So from the name of this chapter you can easily understand that here we are going to talk about motions. Motion means that something is moving, and as this motion is in a straight line, it is also called rectilinear motion. And the subject in which we study ways to understand and describe motion without going into the cause of motion is called the kinematics. Now we don't really bother about the causes of motion here. And what are the causes of motions? Causes of motions can be forces or torque or moment or etc. But in here we are going to only talk about the characteristics of motions. I mean how the object is moving and how we can characterize the movement of that object. Now at this moment the object is moving in this way, and these are some properties of the motion. Then after some time, what will be the properties of motion of that object? All this is about our subject. Okay, so next is reference point and frame of reference. So there are separate videos where we will go in details about these two topics. Here we will just give you an overview. That means the reference point is what that with respect to which point we are going to measure the position of any object. Say, as you already know that in many cases we take origin as a reference point. Okay, so the coordinate is taken as 0, 0 and 0, 0, 0 for 3D. For 2D it is simply 0, 0, and the other points are designated with respect to that origin. Okay, so and what is frame of reference? Frame of reference in case of motion is very important, because if you are on a moving object, then you will see other objects differently, and if you are on a static object, then you will see the same objects differently. Okay, like for a simple example we can talk about that. Say you are on a moving train, and which is moving with velocity say 50 km/h, and there is another train which is moving in the same direction with the same velocity. Then what you will see that the next train is not moving at all. But that is not true, because both the trains are moving. So someone who is standing on a platform which is static, he is looking at both of you, one who is moving with this train, the first train, and one who is moving with the second train. The person standing on the platform, what he will see that both trains are moving with the same velocity, but both are moving. But the people who are in the train, they will think that the people in other train is not moving at all. So here reference frame for the person standing on the platform is the platform. The people who are in the train 1, the reference frame for them is train 1, and the people in the train 2, the reference frame for them is train 2. Okay, so next we will see that what is called position, path length and displacement. Here you will have to understand the difference between distance and displacement. What is distance and what is displacement? Say there are 2 points. One point is point A and the another point is point B. Now you have started moving from point A, and you took this path, and from this locality to that locality, at last you reached the point B. So the path you traversed is the whole length of this path. Okay, and the distance is same. So distance is the path you traversed through this road. But what is displacement? Displacement is the shortest distance between A and B. Okay, and this displacement is a vector, but distance is a scalar. Okay, so displacement is a vector and distance is a scalar. This is to remind. Okay, so next you will see an example of a special kind of motion, that is projectile motion. For projectile motion we will make another short video that will be very much helpful for all the equations related to projectile motion. So in this video we can see that one is throwing a stone and another is catching that stone, and the path the stone is traversing is a curve. So this is called the projectile motion. In this motion the object is under gravity, and also that's why this object is taking a maximum height, and also at the same time it is traversing a horizontal distance. Okay, next we will talk about average velocity and average speed. What is average velocity and what is average speed? Say you and your friend is moving from a point A to a point B. Okay, and the distance between them is 5 km. Now you took say 2 hours and your friend took say 1 hour. Then who has been faster? Obviously your friend took less time, so he is faster. But how can you signify this, or how can you characterize? In this case we will have to take that what was the distance covered by you or your friend per unit time. So what was the distance covered by you per unit time? That is simply the distance covered by you distance by the whole time. So the distance is 5 and you took 2 hours, so that is 5 by 2 km per hour, and that is 2.5 km per hour. For your friend took only 1 hour, so that will be d by t is equal to 5 by 1 is equal to 5 km per hour. So you can see that your friend was faster and he has taken this magnitude higher. Then what is this? We will talk about this. This is the average velocity, that is the total distance by the total time. But it doesn't signify that within this time your friend has been moving constantly with this velocity. Maybe in some times he has decreased his velocity, or maybe in other moments he has increased his velocity. But this is his average velocity and this is your average velocity. So average velocity is what? The distance traversed by you by the time. Okay, so total path length and the speed. For speed it will be the distance or displacement will be replaced by path length. Okay, next in this graph we will see that say on the x-axis the time has been shown, and on the y-axis the distance has been shown. Say at 5 seconds you were here at P1, so the distance is 10, and at 7 seconds you have come to the point P2, which is 27.4. So within this 7 minus 5, 2 seconds, what is the distance that you have traversed? That is 27 minus 4, that is 27 minus 4 minus 10 by time is 7 minus 5, that is 2. So that is 17.4 by 2, and that is what? That is 8.7 meter per second. So this is the average velocity if you calculate from here. Now we will talk about instantaneous velocity. Previously, as we are talking that your friend was moving with average velocity 5 km per hour, doesn't mean that within that hour he has been moving constantly with this velocity. Maybe in some point of time he has taken a velocity higher than this, or maybe in some point of time he has taken velocity less than this. Okay, so what is instantaneous velocity? The instantaneous velocity is the velocity at that instant. That means, say you are moving from your home to school, and you started your journey from home at 10 a.m. okay, and you reached your school at 10:30 a.m. So someone asked you that what was your velocity at 25 a.m. So at that instant, what was the velocity? This is the instantaneous velocity. And to get the instantaneous velocity, we will get to the time that is 10:25. And what we will do, at 10:25 we will look at your position, where are you, and at the next moment, now here comes the tricky part. What will be the next moment? That can be 10:27, that can be 10:30, or that can be even 10:25, but some second after. So after that moment, what will be your position? We will get that position. So what was our average velocity? Average velocity was del x by del t. So now what we will try to do, we will try to minimize this del t. That means to minimize this del t for a particular time. So at 10:25 we will take del t as, say, how much smaller can we take? Okay, that can be even 1 minute. Smaller than 1 minute will be more accurate to the instantaneous velocity, so we can go for, say, 30 seconds. If we decrease the velocity more, then we will get more accurate result. That can be 10 seconds, 5 seconds. That means we will have to take this del t tends to 0. Okay, so that's why the concept of limit or concept of calculus comes here, that v at time t at any instant is ds dt, derivative of the displacement with respect to time, and that can be taken as limit delta t tends to 0, the distance at t plus delta t minus as st, that means divided by delta t. So this delta t, smaller the delta t, the more accurate the instantaneous velocity we can get. Okay, so next is acceleration. Okay, what is acceleration? Acceleration is, so here we will show you some tricky part, that s is v is equal to ds dt. Okay, so rate of change of displacement with respect to time, and acceleration is rate of change of velocity with respect to time. Okay, so dt of v, and v is ds dt, so d dt of ds dt, and that will be simply d2s dt2. Okay, but if we as we get to know that acceleration is nothing but the rate of change of velocity, so we can write as say the velocity previously was u, after time t it is v. So what is the change of velocity? V minus u, and in which time that this change of velocity has taken place? In time t. So this is simply the acceleration, rate of change of velocity, that is velocity change by time. Okay, simply we can get that v is equal to u plus at. So this is a very important equation for motion in straight line. In this figure we can see that the distance can be calculated from the vt graph. On the x-axis it is time, and on the y-axis it is v, and the graph, the area of the graph is always the displacement. Okay, so in here, if the object is moving with constant velocity v for the time t, then the area is this one. So that is the what? That is the total displacement s is equal to vt for constant velocity. But if it has a acceleration a, and acceleration a is what? V minus u by t. So say after some time, say initially the velocity was v0, so this is replaced by v0, and after time t the velocity is v. So what is this length bc? The bc is simply v minus v0, And what is the area of this, the triangle? Half of base into perpendicular, so plus half of base is t into perpendicular is v minus v0. Now what we can do, we can v0 t plus half into, we multiply with t and divide with t, so t into v minus v0 by t. So t square and v minus v0 by t is a, so it simply becomes half at square. Okay, so this is what, this is simply what we get. This is simply s is equal to v0 t plus half a t square. So this is another important theorem that you will have to mind. So these two theorems at first you will have to take into consideration. In next videos we will talk about some more advanced equations. So for this, take two examples. Say one object was moving with velocity 5 meter per second. So u is given as 5 meter per second, and say the acceleration is 2 meter per second square. So after 5 seconds, what will be the velocity v? Okay, so do this, and if you can get the value of v, then please comment in our section. This is a very simple example, you will obviously be able to get it. Okay, so thank you for watching our videos. Don't forget to like, share and comment, and obviously subscribe to our channel. Thank you very much.